Hi, Professor.
Hi there.
I wanted you to meet Watson. This is him. He's the newest member of our little family. He good boy.
Hi, sweetie.
He's a cutie.
He's a good boy. Yeah, he's a football. But yeah, this is him. Mr. Momo. You're gonna be sitting here with me.
All right. Going to learn all about birds. Okay, it looks like somebody's having some internet troubles and keeps going off and coming back on. So you hear a lot of chimes and beeps. That's what's going on. All right, so it looks like, oh, it looks from the chat like most of you guys have spotted the bird. If you haven't, it's right here. And yes, it does look kind of sparrow-like, but it's actually a type of bird called a brown creeper. I actually forgot to take it off the screen. These are similar to nuthatches or woodpeckers that they like to creep up the side of a tree, and they're actually looking for insects tucked into the bark. One of the types of images that I will put up sometimes at the beginning of Zoom is find an animal. Usually it's a lizard. There's a woman on Twitter, Afro Herper, who puts up pictures of lizards that are kind of hard to spot. And so sometimes there'll be those showing up. All right. As usual, there's a quiz this week and a short answer question. Those are both on Blackboard. They're both due Sunday before midnight. Again, they're going to cover the material we're going to talk about this week. So you probably won't be able to answer them until after class on Thursday. Any questions about what we covered last time? We were talking about the different groups of birds and kind of characteristics of all of them.
I have one thing. Hold on, let me turn on my video.
Okay.
From the quiz, I think you called budgies songbirds. Are they songbirds?
They are not songbirds, they're parrots.
That's what I thought. Okay.
Did I write them as songbirds?
Also,
Yeah.
on the quiz, I think it had a lot of questions I think that we're gonna cover today, but
Yeah, I think there were a couple of questions that we haven't covered yet.
but like, hey, I tried my best, so
Yeah, well,
yeah.
if we don't, because I write the quizzes before we cover the material, sometimes I'm going to get out of sync. So if there's a question on the quiz that we don't get to, I'm not going to count those wrong. So I know I have to go back and check the quizzes really carefully from last week.
There were a bunch of questions that we didn't go over, but I happen to know what they were because one of my favorite YouTube channels, which is a reptile channel, Snake Discovery, they own a parrot. And just from watching the one video that they did about her, I was able to answer the question.
I think I know what one you're talking about.
Okay. So last week, I screwed up a little bit on those quizzes. I'm going to have to think about how I'm doing this since I don't want that to be a chronic problem. I may change the schedule a little bit and start putting the quizzes up on Friday and having them do like the following Friday. Kinley, go ahead.
So there was one question that was talking about blood feathers. I don't remember specifically talking about what they are. I had to look that up.
We have not talked about that yet. We will be
Okay.
talking about it today.
Was there, I believe there was a question on last quiz.
There probably was, because I had
Okay.
thought we would get further along in my
Okay.
lecture notes than we did.
I just
last.
wanted to make sure. I just wanted to know. So
Yep. We have not covered blood feathers yet.
Okay.
Okay. Yep. Gonna have to make some changes about the quizzing and the schedules there. All right. Today, we're going to talk about the external anatomy of birds. This is the stuff on the outside. This guy is an umbrella cockatoo. They are one of the most challenging birds to keep as a pet, but they're highly entertaining to watch on YouTube. Okay, so this image and several of the images that we're going to be going through here is from the Cornell Lab of Bird Biology. It is the preeminent, the best respected, I mean, it is the place to go with questions about birds. And so they do have a bunch of information on allaboutbirdbiology.org. It's free, and I stole a lot of their images. So when we're talking about parts of birds, we need to be able to make sure we're using the same language. And some things we know really well. I mean, you know what a wing is, you know what a tail is. Those are very common terms that we're very comfortable with. But then we're going to see a few other terms that are not as commonly used in other animals. We talk about the crown, which is the top of the bird's head. That's not too confusing. We talk about the forehead. One of the things that will be new that we will mention, we're going to talk about the lores. That is the space between the eye and the edge of the beak. We're not going to talk about auriculars. That's the area where the ear would be. We're not going to talk about the malar region. We are going to talk about the throat, the side, the chest, hopefully. You can look at that and you can see those terms and realize where they are. You know, you know where the throat is on you, it's in the same place on the bird. You know where your chest is, it's the same place on the bird.
Diana,
Yes.
could you do me a favor and change the color under lores, just because I'm going to go back over this and get confused about whether that is a thing we're talking about or not.
Yes,
Thank
I
you.
can do that. That's a good point. All right. Okay. Oops. Hang on. There you go. All right. Belly is basically where the belly is. The flank If you probably heard about this, heard this term used with things with various other mammals. It's kind of the same place on a bird. It's kind of the hip region right here. The mantle is the kind of the back of the bird. So that's a term that might be unfamiliar. The rump, it's exactly where you expect a rump to be. And then we've got two terms that you might not be familiar with. In fact, I'm pretty sure unless you've done some reading about birds, you're not familiar with upper tail coverts and undertail coverts. So coverts are a specific type of feather. They are a type of contour feather. We'll talk about what that means. These are feathers that cover the location where a tail or wing feather attaches to the body. So feathers. If you look at a feather, I'm going to stop screen sharing here for a second. Oh, I can't do that and not lose the marking on the screen. All right, so if you can see in the little tiny window, I should be showing up in a little tiny window. The feathers, there's the soft part of the feather starts right about here, and there's this shaft. Part of the shaft is going to be inside the body, in the skin, but there is going to be a little bit of shaft between the skin and the real start of all of this mass of the feathers. So there's a little bit of blank area here. And that's what we're covering with the covert feathers. That helps with insulation, because otherwise you'd have bare skin with no protection against rain or cold temperatures or anything like that. And that's what the coverts cover. And so we have upper tail coverts. That means the top of the tails, and undertail coverts. That's the underside of the tail. And then we also will see a little later on, there are coverts on the wings where the wing feathers attach.
Welcome. So the undertail covert.
So upper tail coverts are right here on the lower back, and they cover where the tail feathers are attached to the body.
Okay, so why is it a different like color on the image than the red? Like, why is it a yellow rather than a red? Because it's still a covert, but it's still a different part, like upper and lower.
Yeah, these are undertail coverts and these are upper tail coverts. They're different colors because they have slightly different names based on the location.
Oh, okay. So, but like, I didn't know if that meant like it was different, like made like differently. Like,
They're not different types of feathers, it's just
Yeah.
a different location.
okay. Cool.
All right. What about the supercilium? Ah,
Isn't that where their ear is?
we're not going to talk about the supercilium. That's underneath the crown. We're not going to talk about that one. Oop. I have to now. Now, we've got a couple of more images here where that are already pre-labeled, and we're not really going to talk about these very much, but I wanted to show these pictures because we are going to talk about some of these areas, and these are really good images that show some of the detail on the head. So hopefully you guys recognize these birds. These are not hawks. These are bald eagles. So
I was like, wait, no, hold on. Yeah, I caught that. I was like, no. Because there was a question about the hawk's beak on the, I think, or the eagle on the quiz, but
okay. So the lure, the seer, the nair, those are the parts that I really want to talk about. The lure is this space between the eye and the beak, so that its skin might be covered with feathers. The seer is the area around the nostril. The nostril is called the nair. So here's our nostril, and the seer is the area around it. Let's go ahead and draw. So this is kind of the seer area right here that I'm coloring. I like these images. I mean, this is a really good picture of this one. The male just kind of looks dorky. You can see some internal structures. We're not really going to discuss the glottis, but that is the entrance to the respiratory tract. So there's an opening in the tongue that leads to the respiratory tract, and then the opening to the throat is kind of behind it. The nair is the opening in the nose. Yes, yes. In bald eagles, the way to tell the different sexes is largely through size. In hawks, owls, and eagles, the female is bigger and the male is going to be smaller.
so, sorry. Hawks, eagles, owls are by size, and then what did you say before that?
Yeah, so you can determine sex in hawks, owls, eagles. The female is larger. In some species, a lot of the passerines, during breeding season, the sexes can be determined by color or by whether they're singing. When we talk about parrots, these can be very, very difficult to determine the sex. Budgies are an exception. And this is what you're thinking about, Laura. And we're going to talk about that in just a second.
Okay, okay. Cool. Yeah.
And this is just another view. I wanted to bring this one up because it has this one term on it that we will be talking about pretty much when we talk about breeding. We talk about the gape, and that is this space along the side of the beak. And we will see that that's one of the ways to determine if a bird is an immature bird versus an adult bird. And again, the female looks like she is not a bird you want to mess with. And the guy kind of looks like he's a little bit dorky. Yeah, the serious villain with the goofy sidekick. That's a good way to put it. Okay, and here's another picture of the seer and the nairs. Here we go to the budgies. I know everybody in the US calls these things parakeets. We are going to call them budgies because parakeet is a broader term, and it basically is referring to any of the small parrots, and budgies are specifically these guys. Budgies, you can determine the sex in most species by looking at the cere.
What the hell? Oh, sorry.
What do you mean in most species?
I'm sorry, not in most species, in most colors. So some of the colors, this does not work. And it's basically blue in males and pink or tan in females. These have to be sexually mature individuals. This does not work with baby budgies.
I was just about to ask. Okay, so. Right.
Yep. Now, there's another thing to look at here with our budgies. And that is their forehead. If you look at the side view on this guy, there are all these stripes on the back of the head. In baby budgies, in very young individuals, those stripes go all the way to the nose. And they gradually lose them from the front to the back.
Which
Kind of like-
stripes?
Huh?
Can you just point to what stripes you're talking about?
These stripes right here on the back of the neck.
Okay, so,
In babies, they go all the way to right here where we find the sears.
okay,
I'm sorry, can you repeat that one more time? I missed that last part.
You know what? I'm going to type it up here.
Okay, thank you.
Stripes on the head go all the way to the cere in babies. And then it starts disappearing. The stripes start disappearing. And I know I misspelled that. From front to back as the bird ages. So where you see this solid colored patch, that tells you that it is a more mature, an older bird. My husband hates it. He's not home to hear this right now, but it's like his hairline. The older he gets, the further back it moves.
oh my God.
Okay. Does everybody understand that?
Just typing this real quick.
Good. So this way, you now know you can walk into a pet store and look at birds and determine if they're young or old. And if they're old, if they're mature, you can tell if they're male or female. I like budgies. I think they do very well in captivity compared to a lot of bird species. Budgies following unhealthy gender roles. Oh, yes, you're exactly right, Maddie. I didn't want to get on the description of sex and gender, so I'm just kind of going with the generic generalist terms, but they're not that accurate. You're right. It is a funny coincidence. And the US, in modern times, we use boys for girls and pink for girls. But 100 years ago, maybe 150 years ago, boys would be dressed in pink and girls would be dressed in blue. So it switches around.
Yeah, because pink was considered like a strong color and then blue was like dainty.
Yep. You're
I was just
exactly
gonna say, it
right.
wasn't, yeah, tough guys or tough people wear pink or whatever.
Yep.
Also,
I saw
heels
one the
and
other day
makeup
that
were
said
invented
tough
for
girls
men.
wear blue.
We just talked at the same time. I'm sorry.
I could hear Maddie saying heels were originally designed for men, which is
Yeah,
also,
and makeup.
and makeup. Yep. Yep.
Makeup, I'm surprised, but
Yeah, because like in the olden days, like high class men would wear like makeup, and it was like a high class thing. Same with heels. And then I don't know when it switched, but
I don't know either, but that's an interesting fact.
Shaving too. That used to be much more of a male thing.
Yeah.
I think it's
But birds don't wear heels and birds don't shave.
imagine if they did.
I mean,
Wow,
if birds are really stressed, they can become naked from plucking,
That is
that
true.
is true.
That is absolutely true.
and they
And
have to wear sweaters.
Yes, yes. And then they get to be embarrassed and people get to dress them up in funny outfits. Yep. We are definitely going to be talking about that issue. Okay. Our next topic is going to be feathers. All right. So when we talk about feathers, different types of feathers on the bird are going to be different in shape. And we can see these differences if we look closely at feathers, and we can tell if the feather is a wing feather, which we also call a flight feather, or a tail feather. And I'm looking at the feathers that I have in my little box, and they're all tail feathers. So let me aha. Okay. Can birds ever be albino? Yes, they can. All right, so tail feathers are easy to identify because they are what we call, I'm sure I've got the right term. They've got this complex shape, and they have this central shaft, and this shape is the shaft is straight, and there's the same amount of feather material to the left of the shaft and to the right.
So it's symmetrical.
They're symmetrical, exactly. A wing feather is also pretty complex, but it's going to have a curved shaft, and there's going to be less feather material on one side of the shaft compared to the other. The side with the less material is going to be towards the head of the bird. Semi-plumes, we're not really going to worry about those. They're kind of they're common, but we're just not gonna worry about those. You're not likely to see those. Contour feathers, these are the feathers that cover the body of the bird. And down feathers also cover the body of the bird, but they're underneath the contour feathers. So I'm gonna stop the share so that you get a good size picture of me. And here, I don't know why I don't see a picture of myself, but this is Sassy. You guys remember her? She's been around for a long while, and her feathers are not great, but you can see she has all of these feathers on her body that are relatively short. They're kind of shaped like a regular feather. You can maybe see that I've got my fingers underneath it there. So you can see how it's basically a feather looking thing. Underneath, she's going to have those downy feathers. This is a flight feather. You can see the distinct curve to the shaft, and this side has a lot less material than this side. So this side would have been towards the head of the bird. This is a tail feather. It's kind of hard to see on this one, but the shaft is relatively straight. There's the same amount of material on each side of the shaft. This is a tail feather. Okay. Where is my little, there we go. So that's how we can identify where feathers came from on a bird. This is another image that kind of shows where we find them. Surface bird feathers, which we also call contour feathers. Subsurface, we have downy feathers, tail feathers in the tail, flight feathers in the wing. Now there's a little bit of a video here, so I want you to pay attention to this. The central portion here, they call it a rachis or rachis. I'm calling it a shaft, same thing. When we look at this, this is a drawing that shows you this microscopic structure of the feather. It has these branches that come off that are called barbs. And each of the barb has branches that come off that are called barbules. So shaft, barb, barbules. And if you look at these barbules, you see that there are these little hooks coming off of them, and they're going to connect to the barbules on the next barb over. Okay, why are you not? So here we see that we've pulled these apart. Oh, the video is not moving very well. Anyway, you can see that they've kind of pulled apart. You can often see that on feathers. So this feather right here, you can see that the connections between this barb and this barb have been lost. Now, I can't fix these. Birds can. One of the things they do when they're preening is they pull these barbs back together and do some wiggling that helps to reconnect the barbules to each other. When we look at the down feathers, we see that they're much more loosely structured. We still have a shaft, we still have barbs, but the barbules are not connected to each other. They don't have those hooks on them that will connect to other barbules. So down feathers are pretty much, they're very useful for insulation. Anytime you want to insulate somebody or something, having air spaces really helps with the insulation. Heat can move from a solid surface to a solid surface, but if you've got an air gap in the middle, it's not as easy for heat to jump across that air gap. So having air gaps slows down the transfer of heat from one surface to another. Not all feathers fit neatly into our categories. I showed you an emu feather that looked a lot like this one. This particular one is from a cassowary. Same structure. It's very loose. It has two shafts on the same feather. And if we look at the image on the left, we are seeing they look almost hair-like. It's only when you get them off the bird and you spread out the sides of it that you can see that these are feathers and not hairs. The raytite feathers, our emu, our cassowary, our ostrich, are probably the most like the ones found on T-Rex and found on early non-avian dinosaurs. So I think I showed you this last time. This is a from a tail of an early dinosaur, one of the earlier feathered dinosaurs. We can see this is a 2017 image that is the best estimate of what they looked like. That's a very good question, Jess. That's why I say it's the best estimate. We know that T-Rex had feathers at least when they were young and small. We think they had the feathers when they were small and lost them when they were older. So they quite possibly grew out of them. So this would kind of be, probably like a teenage T-Rex, not a mature adult. They probably had less feathering on them when they were fully mature, more when they were younger. These are educated guesses. I mean, we can see that at some life stages they had feathers, but other fossils that we have just show the scales and don't show feathers. So that's why we think that the young ones were feathered and they grew out of it. Yes. We think that the purpose of these feathers on the giant dinosaurs like T-Rex was insulation for the juveniles. T-Rex and dinosaurs of that type, the archosaurs of that size, probably were somewhat warm-blooded. And while we think about warm blood, we think about, well, our body temperature stays stable. But it also means our body temperature has to stay stable. If your internal body temperature drops too far, you go into hypothermia and you're in trouble. If it goes too high, it's hyperthermia, and that can also kill you very quickly. So what we think is that the feathers on the juvenile T-Rexes helped them maintain the right body temperature. And when they got bigger, they didn't need those feathers because larger animals tend not to have problems with getting too cold just because of their body mass and their activity level. They're more likely to get too hot. So they tend not to have fur in things like rhinoceros and elephant. And we think feathers in the T-Rex. Yes, you got me off track, but that's okay. All right. This guy is we call these guys, oh, I don't have the name written down. It's another archosaur or theropod. And you can see that it had what looked like flight feathers on the hind leg as well as the front leg. Somebody colored it up like a fruit dove. We know less about the color of early feathers than we know about the structure of early feathers. We're starting, it might be Microraptor. Yeah, Daniel. We're starting to understand or be able to find information on some pigments, but it's really largely a guess at this point. We can tell that this was a non-avian dinosaur because it doesn't have a beak structure. There's going to be teeth in here, and this tail, the feathers are not connected to the body like they are in modern birds. They're connected to a long tail that's going to have vertebra in it, just like your cat's tail or your dog's tail. And this is a fossil. I think it's probably this guy. You can see long feathers on the wings, on the tail. I'm sorry, on the hind legs. You can't really see them on the tail in this image. Okay. So when we look at the feathers on the wings, let me get my annotation tool. We can describe the flight feathers on the wings in a couple of terms. The primaries, or the primary flight feathers, are the ones that are toward the front of the wing. So if the bird had its wings spread out, the primaries would be towards the front. The secondaries would be closer to the bottom. The covert feathers on the wings are divided into primary and secondary as well. The primary coverts, if you ever forget this, it's got cover written right there. The primary coverts cover where the primary feathers attach. The secondary coverts cover where the secondary feathers attach. So here we can see this again. These are the secondary flight feathers with our secondary coverts. These are our primary flight feathers with our primary coverts. We're not going to worry about any of the other terms on here. So let me go ahead and mark those off for you. Not worried about that one, not worried about that one, or that one. Just primaries and secondaries and primary and secondary coverts. On the underside of the wing, we can also see the primaries. It's just the underside of the primaries, the underside of the secondaries, and there are underwing coverts. So we can see underwing coverts that cover where those long feathers attach to the body. And unlike the top where we separate the coverts into primary and secondary, we just call these underwing. These feathers are kind of weird looking feathers. These are called rictal bristles. They're very stiff. They're much more like a really stiff hair. So they're not very feathery looking, right? They look much more like a hair, but they are stiff, and they are found around the beak on birds that catch insects in flight. Now, we do not think that they work like whiskers. This is what would, this would make sense, right? It's kind of working either as whiskers to detect insects or to help funnel insects into the mouth. We don't think they do that. These birds can catch just as many insects if you remove the rictal bristles as if they have them. What we think the function is actually protecting the eye. So if you look, you can see there's a lot of them over here on the side. When this bird is catching insects in flight, he's got his mouth open, those rictal bristles are coming out almost straight out from the face. And any insect that they miss, if the insect dodges the beak, instead of going into the eye, it'll bounce off those bristles and protect the eye from damage. Because you can imagine if you're catching insects while you're flying, it would be very easy to have one land in your eye and scratch the cornea, and then you're in a lot of trouble there. All right, so those are the different kinds of feathers. Now I want to talk about how feathers grow. Just like your hair, there is going to be a structure embedded in the skin, which is where the feather starts growing from. In the case of growing feathers, there is a blood supply in the skin. They start coming out in this folded structure, and then eventually will open up into the proper feather structure. Just like the hairs on your body, there are muscles that can help pull the feathers out. So if you've ever seen a bird stick its feathers out and kind of ruffle its feathers, that's the same thing as if you get goosebumps. Feathers are predominantly made from keratin. Keratin is the same thing that you find in hair, nails, skin cells, horns, claws, hooves, fur, all of that is made from keratin. So those,
Not horns, antlers. Horns are bone.
horns have a base of bone, but it's covered with keratin.
Oh. And are antlers,
Similar thing. Antlers, okay, antlers grow every year.
yeah,
Well, let me put it this way.
they're not part of the skeleton.
They're not part of the skeleton, right? Horns are not always bony on the inside. So if we think about rhinoceros horns, for example, those are made completely of keratin. They're specialized hairs. There's not a blood supply in there. You can cut off a rhino's horn while the animal is alive. It's not going to bleed. It's not going to hurt the animal at all. It's like you getting a haircut. So I'm using horn in the more general term rather than being biologically exact. So yes, rhinos are killed for their horns, which is made of the same thing as your hair and bird feathers. All right, so when feathers start growing, they have a blood supply in them. Okay, looks like Daniel looked up the details. Antlers are bone and horns are keratin. Antlers need more blood supply than horns. Okay. I'm going to plead this is a bird class, not a mammal class card. All right, so these are growing feathers that we call blood feathers. We call them that because there is a blood supply inside the feather. They have this clear, almost plastic looking sheath around them to help wrap them. And it's when they get longer and the sheath will start breaking down at this end, and the feathers will then open up and start forming regular feather structures. Now, the problem with blood feathers, if these are broken and the blood on the inside is exposed, the shaft then acts basically like a straw. The blood comes out the shaft, and it comes out in such a volume and such a speed that it's not likely to clot, or it'll take a while to clot. And the bird can bleed to death. So a broken blood feather is an emergency. These are broken blood feathers here. You can see the blood still in the shaft here, blood at the base here. Notice that they're almost fully grown out. So as they grow, the blood supply shrinks further back towards the body. And so you don't have blood here. You don't really have much blood on the inside here, but you can really see there's this nice line where the blood starts. So this is a broken blood feather on a bird. You can see it's bleeding out. There's blood everywhere. This is not good. So we consider this an emergency. So yes, we're going to talk about what to do right now. So step one, stop the bleeding. Now, how well you can do this is going to vary from bird to bird. Your bird might be freaking out, and you may need to wrap the bird in a towel. So I'm going to stop screen sharing here for a second. And I'm going to introduce you to a bird. So this flamingo, last spring's class named her. I don't remember what they named her though. If she breaks a blood feather, she's freaking out, she's not happy. What I'm going to do is put a towel around, keeping her wing out, and I'm going to cover her head gently so that she can't see, and I'm going to hold her gently. We haven't talked about holding birds. This kind of restraint is largely for, we'll talk in more detail about how you restrain each individual bird, but a small bird with a broken blood feather, a good way to hold them is to have the wing kind of between your fingers, so you can work on that wing while still holding on to the bird. Once you've restrained the bird, or the bird is calm because it's a calm bird, then we stop the bleeding. And when we stop the bleeding, yes, we can use quick stop, the same stuff that you would use on your cat's nails if you cut them too short. Available at any pet store, any vet, the quick stop is fine. There are products at the drugstore that are designed to be used on people when they get shaving nicks. Some of those can be toxic to birds. So don't use something that's designed for people. Quick stop is fine. What happens if you don't have quick stop? Well, there are emergency alternatives. Flour is a great emergency alternative. It has a similar texture to quick flour or quick stop. And it helps with clotting. I see people in the chat are saying cornstarch. Cornstarch is another good one. That also can help with the clotting, as can baking soda. These are things that you probably have in your kitchen. You may have to apply pressure to the wound to get the bleeding to stop, even using quick stop or flour or cornstarch. Do not use silver nitrate. I see Maddie put silver something. Don't use that on birds. That's toxic for birds. Would I recommend flour over cornstarch? I like flour because it's in the front of my kitchen cabinet. I probably have cornstarch in the back of the cabinet. Flour is quicker and easier for me to grab. Quick Start has silver nitrite in it. Are you sure about that, Maddie? I may be thinking of something else, but I thought the silver nitrate was not good. That's the one your reptile shop used. Okay, so I will double check the silver nitrite thing. I may be thinking of a different chemical that's the problem for birds. I know Quick Stop is safe for them. Yes, aluminum nitrate. That may be it. It's a metal. I'm pretty sure it's a metal nitrate. Metal, some metal in a nitrate. Okay. Baking soda has aluminum. Woo. Okay, here's the thing. I know that there's a chemical that's sometimes used on people that can't be used on birds. And I've been trying to remember what it was. And obviously I have no clue what it was. These are the things I know are safe. You guys are on the ball today. You're catching me off my game.
So I guess some Quick Stops contain silver nitrate, and that is the one that is toxic.
Okay.
And here it says that a lot of people, or at least this specific one, says they don't use it because they're afraid of getting the powder in the bird's mouth. But I
Okay.
mean, just like everything, each brand is going to have slightly different ingredients.
Yep. Yep.
I guess the one that we used must have just had the silver in it.
Okay. Well, thank you for looking that up. If you're concerned about that, which I would be, use flour. I use flour when I trim my cat's nails, if I cut them. It's very rare for me to cut them, but if I do cut them and they're bleeding, I just use flour. I don't even have Quick Stop in the house because flour does the job. All right. If you get the bleeding stopped, the bird still needs to go to the vet because the structure of that broken feather being kind of like a straw with a wide opening at the end means that there's a chance that it will start bleeding again. And so what has to be done is the blood feather has to be pulled. Not cut, pulled. This is a appropriately pulled blood feather. You can see this bulbous end. That means the shaft has been completely removed from the skin and we can control the bleeding. And it won't be life-threatening to the bird at that point. So owners can learn how to do this, but you want to make sure that, sorry, I was reading a comment. You want to have a vet show you how to do it and make sure that you know how to do it, because if you try and pull it and it breaks down here, that's going to be very difficult to get that last little bit out. The Stone Zoo uses silver nitrate for bumblefoot on the flamingos. Okay. Do they have a lot of bumblefoot? I know that enclosure gets filthy. Okay, so this is a mature feather. You can see the shaft is clear. There's no blood in it. This is a pulled blood feather. And you can see the dark coloration here. That's the blood inside that feather. but because we pulled the bulb, it's not bleeding out this end. So the opening, what's going on here is the opening at the end where the blood vessel comes through is narrower. It's smaller than the size of the shaft. So the shaft is much wider. So if you break the shaft, you've got a wider opening. If you pull the blood feather, you're certainly breaking the end of that blood vessel, but it's a much smaller size opening at that point. So it's easier to get the blood clotted and have it working well there. Working well, having the bleeding stop. Here's a mature feather, here's another blood feather. Mature feathers are essentially dead. Just like your hair is essentially dead. Everything you see in your hair, there's no blood supply, there's no nerve supply, it's dead material. Okay. Feathers wear out. They are critical for warmth, for flight, and sometimes for camouflage. If we think about sparrow-looking birds, they can be hard to spot on the ground or on their nest. We're going to talk about bumblefoot in a second. I'm going to come back to your comments, Daniel, because that's kind of interesting. So molting is when old feathers come out, they fall out of the bird, and they're replaced with by new feathers. This usually occurs a few feathers at a time, especially when we're talking about flight feathers. So this image at the top, these are the primary flight feathers here. These may be their secondaries here, it looks like it. And you can see these two short ones in between. So generally what happens with flight feathers is the bird will lose one or two. They'll fly with the rest of their flight feathers as those one or two are growing in. Once the first ones they've lost have grown in, they're going to lose two more. One or two more. When those have grown back in, they'll lose one or two more. You can see the forehead of this budgie. It's got these little feathers starting to come back in. Some species, like chickens, will molt huge percentage of their body all at once. So you can see all of the blood feathers here on this chicken. It's lost a lot of its feathers. It's, you know, mangy looking. It looks pretty ugly. Birds tend to be very cranky when they are molting, especially if they do these most of the body molts. So if you have pet chickens, they won't lay eggs while they're molting. And of course, this is biology, so sometimes they do. So with flight feathers, we've got our molting going a couple at a time. Yes, chickens in molt don't look very good. They do look sick. With the sequential molt on flight feathers, you'll notice that there's one feather missing here. There's a short one growing in. And at about the same spot on the other wing, there's one growing in. Once that one grows in, they'll lose the next one. We say sequential because they kind of go in order. So you lose the one closest to the body, that one grows back in, then you lose the next one, and the next one, and the next one. So you're just going in a sequence. Molts often occur just before migration season. And it may be one time, it may be only in the fall, for example, or it may be both in the fall and in the spring. Why do birds molt right before they migrate? Any guesses?
Because you want to fly long distances on good feathers.
Yeah, you want to have good feathers to fly those long distances. Exactly. Waterfowl does do molts where they lose all of their flight feathers at once. So you can see this guy, he's lost all of his flight feathers. He's got all blood feathers here. This means that waterfowl, ducks and geese and swans cannot fly until the new feathers come in. And this can take 20 or 30 days, 20 or 40 days, I'm sorry. Waterfowl does this, they can do this all at once because they can get on the water. And so they don't have to fly away from land-based predators. They can just be on the water. They are vulnerable to predators during this time, though. It's actually, as far as I can tell, not painful to have those flight feathers exposed, or those blood feathers exposed. Most of the nerves are inside the body at the base of that feather. So if they bang them on something and they bend them, that might be uncomfortable. But it's kind of like, well, they're still growing, so they do have a blood supply, but not a nerve supply. It takes protein to grow feathers. That is an important fact right there. Do wild birds often die from broken blood feathers? No. The reason why it's more of a problem in captive birds than wild birds is because captive birds have less space. If they're in a cage or flying free in the house, they've got walls around them that they're more likely to run into than a bird that is living in a grassland and can just, take off, and there's nothing for them to bang their wings against, or there's not as much to bang their wings against. So that's the difference between captive and wild there. Okay, so it takes protein to grow feathers, which means that if your captive bird is molting, you want to make sure they're getting protein in the diet. Otherwise, they can have problems growing those new feathers. They can come in abnormal. They can, take a longer time period to grow in and that kind of stuff. The protein need for new feathers is why almost all bird species are insect eaters for the first few months of life. So sparrows that normally eat seed will catch insects to feed their young. What form of protein would a captive bird eat? They can eat things like mealworms. They can eat hard-boiled or scrambled egg, especially if it's got the shell broken up in it. Those are the primary protein sources that you would give to captive birds. I'm trying to think. But yeah, they would be animal products or even insects. If you want to grow your own cockroaches and feed them naked cockroaches. Oyster shells are good for calcium. I don't know that they're a good source of protein, however. Birds certainly need a source of calcium. Yeah, dubia roaches, yeah, those would probably be really good, especially if you feed them while they're in the process of molting, when the roaches are molting. And they're nice and soft and squishy. Okay, so it looks like we're almost out of time. What kinds of questions do you guys have before we end this? Yes, Kinley.
It's a more of a, I learn better when I see a picture. So can I print these pictures out and put them into my notebook to remind me of what we're talking about?
Yes, absolutely. They're available in this week's module. So it'll say PP and then the date. PP stands for PowerPoint. Any other questions? All right.
Yeah, actually, since the last quiz was mostly on like the stuff that we did today. If we see that like the next one is on like stuff that we haven't covered yet, should we just wait?
I'm going to think about this over the next 2 days, and I will tell you my new plan about quizzes on next time we meet on Thursday.
Okay, cool. Awesome. Thank you.
You're welcome. Mary Kate, you got your hand up?
I just wanted to say that Anne from North Shore in Danvers says hello.
Anne?
Yeah, she's from Student Engagement.
Oh, okay.
I was talking to her about the class today and she said to say hi.
Okay, thanks. If you talk to her again, say hi back.
I will.
Betsy, you've got your hand up?
I do. So like how long can it, I know it probably differs from bird to bird, but how long can feathers take to grow back?
Oh, it does vary from bird to bird, and it varies from feather type to feather type. So it can be, I mentioned with the waterfowl who are growing in their flight feathers all at once, that it can take on some species up to 40 days. I think that that's kind of the long end of things. I don't have a good grasp of the short end of things. That's a good question that I don't know the answer to. I will look that up and let you know next time. You guys are keeping me on my toes today. Anything else? Daniel, go ahead.
Yes, I just wanted to add up about my comment about the flamingos and about the zoo.
Mhm.
So it was just really briefly that I was learning about the type of silver spray that they were using for their feet, which I knew that it was like a semi like toxic, but it was fine since they were also going to be like in their pool right after we were treating them. And
Okay.
I do have to say, like, their pool is not really properly designed for them, so that's the issue for their bumblefoot.
Yeah. Yeah. That's what I was thinking. And when we talk about feet, next time, dirty enclosures are a major cause of bumblefoot, which is a very common foot disease that birds get. So yeah,
Mhm.
I suspected that was the reason that the flamingos get bumblefoot so much. Assuming
Yeah.
it's a lot. Yeah. It's amazing they can be outside most of the year there. Obviously, they can tolerate cold weather pretty good.
Mhm.
Okay. I will see you guys next time. I got some research to do and I'll come back with some answers to some of these questions. Bye, everybody.